symptoms: frequent distressing recollections, nightmares, avoidance of reminders of the event, and exaggerated arousal in response to noise. Post-traumatic stress disorder occurs in some people after terrifying experiences and includes the following symptoms: frequent distressing recollections, nightmares, avoidance of reminders of the event, and exaggerated arousal in response to noises and other stimuli. So again, this is something that I took out of the textbook. So it seems as if when something is so intense that the amygdala becomes very, very primed to it was such a shocking experience that the amygdala can go on a full alert. And so the amygdala is tied in right with the hippocampus, so when they think about it, it's causing all these problems. It's as if it makes the amygdala, it doesn't really do this, but this is a way to think about it, is it's as if it makes the amygdala like grow and become much stronger because it got attacked so violently, so unexpectedly, so strongly that the amygdala became very sensitized. And so the amygdala becomes active during sleep. You have lots of nightmares, and they have an increased startle reflex. Let's see if that's what's on our next slide, because the startle reflex is a measure of anxiety. I guess that I don't have it here, so we'll go back to anxiety when we get to that here. Okay, what is emotion? So we learned already in Chapter 4 that the limbic system, remember that? We had the amygdala, the hippocampus are part of the limbic system, and then other structures that are involved in regulating emotion are the thalamus, the hypothalamus, the cingulate gyrus, the striatum. We'll be talking about that. So it's been regarded as critical for emotion, but PET scans and fMRI scans suggest that many other areas of the cerebral cortex, especially the frontal lobe and temporal lobes, are activated during an emotional experience. So they used to think that the limbic system was the primary source of emotion, and they're still saying that, but they're saying that emotion is spread out throughout the brain. And so on the next slide I have pictures of this. Okay? So these are all the different brain areas that are part of the limbic system. The olfactory bulbs are, you know how they say dogs can smell fear? There might be some of that with us. Like when you just feel it, you say, I don't know why, but I just feel it. It could be that the pheromones that people release in different emotional states can affect this. And then you've got the hippocampus and the amygdala, the mammillary bodies, cingulate gyrus. Okay. So we already talked about a lot of things on this slide, that emotions probably aren't localized in a specific portion of the cortex, that the emotions are located all around the cortex. And then another thing about that this slide is focusing on is that we tend to attend strongly to facial expressions. So other people's facial expressions seem to really influence our emotional state, and that's something very, very, very important to remember, is about these mirror neurons. I'm not sure if we have had a video on mirror neurons in this class, but I'm definitely going to show it to you, probably maybe as part of this module. Is when we look at another person, what their reactions are will influence our own mirror neurons in our brain. So when we look at someone else, that person's facial patterns can actually mirror into our brain and make us start to feel what they feel. That's empathy. And some of us have larger mirror neuron areas than others, and that's why some of us might be more empathetic than others. In autism in particular, they think that that's a problem, is that their mirror neuron system is not working very well, and so they can't feel what other people feel. Sorry about that. But the reason why I said this is important for us to remember is it's important for you to remember that if you walk around negative all the time, you're not just affecting yourself, you're affecting the people around you. Because when they see your negative face and when they see you upset, it actually causes them to start feeling upset. So by you acting positive, it actually can help other people act positive. And I always do this in my classes. I walk around and I smile at them in their faces. Now, of course, there's some that just are going to beat me out and they're just going to not smile at me. But most people, when I walk and I smile at them, they immediately start to smile. And then I start laughing. And laughing, laughing, laughing. And you'll soon see, first the class is kind of shocked. Like, what the heck is she doing? But then when I keep laughing, they start to laugh. And I try to show them, look, this is the mirror neuron system. Why is it on cartoons that a lot of times you'll have the audience in the background laughing? And that causes you to see things as more funny. So this is something for you to remember, that your emotional state actually influences other people's emotional state. Here's me trying to show you, this is coming from a textbook, of how spread out all the different emotions are in the brain. And you can take a look at this, but this picture is coming from your textbook, is they're widely spread. The only one that they are saying like tends to be a little bit more localized is disgust. So I'll let you take a look at this in your textbook. Okay, so localization in the brain seems to exist for the emotion of disgust. This is pretty recent research. Like, this came out in this edition of the textbook. It hasn't been in the past editions of the textbook. The insular cortex is strongly activated during exposure to stimuli perceived as disgusting. Also, when we think things as disgusting, we say, oh, it leaves a bad taste in my mouth. And the insular cortex, when it's stimulated, it actually stimulates our taste cortex, which is interesting because we have that statement. It says, I don't know, it just makes me feel disgusted. It just leaves a bad taste in my mouth. That's exactly what it does do. When we feel that something is disgusting, it stimulates our taste cortex. Also, it reacts to frightening stimuli, so it's not completely dedicated to disgust. So let's go back and see. Okay, green is disgust, and the insular cortex is going to be right in this area. Okay. So the two hemispheres of the brain play a different role in emotion. We talked about this in chapter 14. We talked about that the left hemisphere is more related for positive emotion, and the right hemisphere is more involved in negative emotion. But in this chapter, we're getting another term that's associated with this. The left hemisphere is associated with approach and the behavioral activation system. It's marked by low to moderate arousal, and it can characterize either happiness or anger, but it's more of an approach system. I never know how fast to go with this. I'll just specify the points. I don't even think you need to write down too much here, but here the main point is that what we've learned in the past is that the right hemisphere and left hemisphere play different roles in emotion. You should already have that. You know that from chapter 14. And then the left hemisphere seems to be more with approach behavior. It's less of a depressed behavior. A depressed behavior is just, I'm going to retract, whereas the left hemisphere is more, I'm going to approach, I'm going to go out, I'm going to do this. Okay, so then the right hemisphere is more of your behavioral inhibition system. So it's more, remember we talked about that the right hemisphere is more involved in depression. It's more in, I'm going to retract, I'm going to isolate, I'm going to be alone. Okay, it's associated with increased frontal temporal lobe of the right hemisphere. It increases attention and arousal, but it inhibits action. That's what we're talking about, like depression. It stimulates emotions such as fear and disgust. Okay, right hemisphere is more inhibitory of the action, and it's associated with the behavioral inhibition system. Okay, so differences in the frontal cortex activity relate to the personality. So people who are more aloof, more isolating, would be more right hemisphere activity stimulated. Whereas people who are more outgoing, I'm out there, I'm going to do this, I'm going to be more social, would be more left hemisphere activity.